Hello there, my name is Florian and I welcome you to IT Tech Tips. Today I'm talking about a topic which is super important for the functionality of the modern internet, but even many IT professionals don't know the details about. I'm talking about DNS, the Domain Name Service. So without further ado, let's have a look. DNS, the Domain Name Service, is kind of the phone book of the internet. For simplicity reasons, I'm not going to talk about DNS in an IP version 6 environment. I'm only using IPv4 in this presentation, and I also will not go into topics like clustering, load balancing and split brain DNS. The basic principles are the same for IP4 and IP6. Every device which is reachable on the internet has an IP address like 46.140.106.19 or 84.116.200.241. So IP addresses are kind of hard to remember. It's much easier to remember names like acmecorp.com instead of 72.14.221.112 or cnn.com. So what we need is kind of a phone book to look up an IP address if we only know the name. As I said, DNS stands for Domain Name Service. This is our phone book. So in conclusion, the basic principles of DNS are very simple. I give you a domain name and you return an IP address. This is also called a forward lookup. The reverse lookup would be the reverse. I give you an IP address and you return the domain name. This only works in specific conditions, but is used sometimes. Now let's have a look at the hierarchy of DNS. DNS is built top down. So at the top we have the root level, and below that we have the common endings like com, gov, net, your country like ch or EU or US, etc. Then on the next level below that we have the domain names. You know, for a specific domain, for example acmecorp.com, somecountry.gov, opensource.net, stackexchange.net, cnn.com, google.com, etc. And as you can see, the name grows in length, delimited by a dot between the parts in the domain name. You can go one level lower, and then you have the common prefixes you mostly use like www, files, etc. You can do that as much as you want. To my knowledge, there's no theoretical limit to the amount of levels you can have in a DNS system, but in practice it's usually 3 or 4 levels. As you can see, you can go further. At the top of the hierarchy there's the root level, which is just the dot and you rarely come into contact with it. Below that there's the top level, which is usually in practice the top level you're using. That's how you can remember it. Below that the second level, the third level, etc. Now let's dissect acmecorp.com. Com is the top level, as we've learned on the last slide. Then the second level is Acme Corp. And each of these parts, com and Acme Corp, are called a zone. WW is not a zone, but we'll get to that later. Each and every DNS server knows the servers in the next lower hierarchy below this zone. So as an example, you have a top level server for .com, and this one knows the second level Microsoft or Google or Acme Corp. If we go further down, we have the third level. For example, the google.com DNS server knows the third level domain names like www, FTP, login, which would result in the domain name www.google.com. The same goes for every second level domain. Now the lowest level zone contains IP addresses within this zone. Let's have a look at the zone acmecorp.com, which we used on the previous slide. One entry is www with its IP address, but there could be many more entries like FTP or mail, which would result in mail.acmecorp.com. These entries in the lowest level of a zone are called records. That's why I said www is not a zone in the last example. There are various types of records. For example, the most popular one is probably the A record, which contains an IP4 address for a name, like www. Then there's the CNAME record, which acts like an alias, and it contains a name for another name. Like for example, web could refer to www, or internet could refer to www. Why should you use a CNAME record? Because it allows you to care about fewer IP addresses. For example, you could have a server which provides many services, and then you could have just an A record for server1.acmecorp.com and refer to it by CNAME records like www, FTP, files, PBX, etc. And if you need to change the IP address of the server 1, you could just change the A record and everything would continue working just fine. Then there's the MX record, which is used for mail server. It contains IP addresses for mail servers in a zone. Usually they're called like mail, so mail.acmecorp.com. And then there's the text record, which is kind of the joker record you can use for anything you want. It's often used by applications to distribute configurations if it's not done by DHCP, or for additional security or zone authentication. For example, if you need to prove to a provider that you are the owner of the zone, or at least you have access to the zone, the provider can tell you to create a text record in the zone with a specific, really long usually key, and then you enter this key in a text record and the provider will check with a DNS forward query if this record exists, and if it does, you have proven that you own this zone. Let's do a quick case study to see this theory in practice. You enter www.acmecorp.com in your web browser. Your operating system knows which DNS server to ask first. For example, in smaller home networks, it's usually 192.168.1.1, or the Google DNS server is really popular, 4x8. So the operating system is asking the first DNS server, give me the IP for www.acmecorp.com. But this DNS server usually does not know www.acmecorp.com and asks the DNS server which is responsible for .com. Give me the IP for www.acmecorp.com. And this DNS server knows the responsible DNS server for acmecorp.com. Remember, each DNS server knows the DNS servers for its zone, which are one level below. So it will ask the DNS server for acmecorp.com, give me the IP for www.acmecorp.com. And this DNS server will then finally return the IP address. And the web browser will ask the web server on this IP address to provide the data for the web page. So, as you can see, there's a lot going on in the background when you're accessing a web page. In conclusion, many DNS queries go through multiple layers of hierarchy. So it's this server, this server, this server, and finally some DNS server knows the answer and returns the answer. So because many levels of hierarchy are involved, a query sometimes times out because each level of hierarchy needs some time to ask another level of hierarchy, and this amount of time sums up. And there is a timeout defined for DNS queries. It's usually a few seconds, and if this time is not enough, the first DNS query will time out, but subsequent DNS queries usually will not time out because all DNS server in this chain of DNS server will cache the responses from the other DNS server and will then be able to return you an answer directly. The example in the case study is called a recursive query. That means the first DNS server delegates the query to the other DNS servers. Another case study would be an iterative query. That's when the DNS server who is asked first, in our example the one local in our network, handles all levels of hierarchy lookups itself. So it will ask the first DNS server, then it will ask the second DNS server, then it will ask the third DNS server, and then it will itself return the response. So there's recursive queries and iterative queries. In summary, DNS is a very important service for a functioning internet. Many application errors, if your application cannot reach a server for example, originate in a bad DNS server or a bad client configuration for DNS settings. To see how DNS works in practice, watch the episode where we configure a DNS server in a lab environment. This episode is linked at the end of this episode. So if you liked this episode and you don't want to miss any other topics that I'm covering in future episodes, I suggest that you subscribe to this channel and ring the bell so you get notified. I hope you liked it. See you next time.